Hi, it's Glenn with your details for your lab report on simple and fractional distillations. For your abstract, please say what you did, what techniques you used, simple and fractional distillation, and then please report the mole fractions that you found on your gas chromatograms, and then please report whether or not there was the expected difference in the graph's appearances. The graphs, I will tell you how to make your graphs. And there's an appearance that you should expect, and then there's the appearance that you actually got. So I'm not sure how that's going to turn out for you, but more soon. Introduction section, please make sure that somewhere in the introduction you address the question of what is simple distillation used for versus what is fractional distillation used for. Obviously, they're used for different things, yes? So they're not used for exactly the same thing. Also, please answer the question, how does the condenser full of beads that you used make fractional distillation different than simple distillation? So the main difference for us was that condenser full of beads. And why was that? Why did that make a difference? Exactly what is that supposed to do? Please be as detailed as you can. In the procedures, yes, you just have to, put the procedures in your own words. I encourage you to draw pictures. If you draw pictures, you don't have to use as many words, right? Also, make sure that you show me that you know which parts of your apparatus must be greased and clipped. Those yellow clips, the cat clips, yes. And which parts do not need to be greased and clipped. Also, be sure to mention exactly where the thermometer needs to go. There were several groups who were putting the thermometer in the wrong spot. Please let me know that you know exactly how high that thermometer should be sitting over in that thermometer adapter or inlet adapter, part of your apparatus. In the results and data section, please please draw this graph. Let me show you. You just use Microsoft Excel or Numbers or Google Sheets, and I want you to graph on the x-axis the milliliters of the distillate that you received. At some point in your distillation, both the simple and fractional, you were writing down the temperature every 0.5 milliliters of distillate received. So for every temperature that you have there, every piece of temperature data, please put on your spreadsheet software the milliliters of distillate that you received. Now, some of you may have just done like this. You may have recorded the temperature every 0.5 milliliters, kind of like this. That's okay. Just add them up together so that it ends up being total milliliters of distillate. Some of you may have started collecting that data at 5 milliliters. That's okay too. Just include the data that you actually recorded. Make it cumulative so that the temperature that you write down here is the temperature that you recorded when you passed a total of this amount of distillate into your graduated cylinder. You know what I mean? I hope that's clear. I didn't quite explain that very clearly, but I hope you know what I mean. If you have questions, please send me email. Here, let me try to be a little clearer there. So, in this distillation apparatus, for example. So, as I collect the distillates, after it reaches maybe 5 milliliters, I start recording the temperature every 0.5 milliliters. So it's like 66 at 5 milliliters, and then it's 72 at the next 0.5 milliliters. So that means 5.5. So 66 at 5 and 72 at 5.5. The next 0.5 milliliters, let's say it was like 81. That means it's 81 at 6 milliliters, actually 6.0. Okay? So is that clearer? I hope so. I think the maximum volume of distillates that you received was probably going to be 15 or something around there. You just have to put this on the x-axis and this on the y-axis. You have to do it for simple distillation. You have to do it again for fractional distillation. And then you have to graph them. Why? Because I want to see if you had any results that looked like this. Not like that. Like this. Yeah, like this. See this? Look at this beautiful graph. Look how the simple distillation curve is kind of amorphous, whereas the fractional distillation curve is much more well-defined. This is where we got rid of the hexane, and this is where we got rid of the toluene. So, does your graph look like this? This is the expected result. If you have the expected result, say so in your abstract, and if you don't have the expected result, just say that that your simple and fractional distillation graphs of temperature versus volume of distillate did not appear to be did not appear to match the expected result. So I'm not saying that this is the graph that you need to have. I'm just saying that the shape of the curve needs to be something, or should have been something like this. And if it wasn't, you should explain why. On your graph, you must have the title, simple versus fractional distillation. You must have the y-axis having the word temperature, and then it could be temperature of vapors, but you also have to have the units. The x-axis, it has to have milliliters. It also has to say distillates, because we're not interested in the milliliters of the mixture. We're interested in the milliliters of the distillates. So let's see. You can graph this on two separate graphs if you want, the fractional distillation on one graph, the simple distillation on a separate graph if you want, as long as you have all these features: title, axis label, and you must label the graphs. I mean the curves. You must tell me that this, you know that this is the simple distillation, and you know that this is the fractional distillation. Okay. So those are the graphs that you must post in your results and data section. Also, please show me the mole fractions from gas chromatograms. Now, for that, there's going to be a sample calculation. Please show me that you know how to calculate the mole fractions from your gas chromatograms. Those of you who ran out of time and didn't take a picture of your own gas chromatograms, I took your gas chromatograms for you, and they're somewhere around here. Here they are. I posted in the news forum on the Moodle a link to this Google Photos page where I have some gas chromatograms from some people who ran out of time. From some people who ran out of time. So this is how to calculate the mole fractions. It is the area under the peak that you think is hexane or that you think is toluene, divided by the total area, this bottom number with no retention time. It is the total area of the on the gas chromatogram. So this area divided by this area, that's the mole fraction of this thing. What is this thing? Well, you have to figure out what this thing is. It's either hexane or toluene or some impurity that we don't know about. The hexane has a boiling point that is different from the boiling point of toluene. Remember that the high boiling points will have a larger retention time. The low boiling points will have a shorter retention time. If the boiling point between hexane and toluene is very different, if those boiling points are very different, then the retention time should also be very different. These retention times, about 7 minutes and about 8 minutes, retention time is given in minutes here. These retention times are quite similar. Here, in this case, it is not the case that one of these is hexane and the other is toluene. Why? Because the retention times are so close together. It's probably the case that one of these is some impurity that we don't know about, and one of them is, and the other one is either hexane or toluene. But that is not a certainty, you know. It may very well be that one of these is hexane and one of these is toluene, and the gas chromatogram just ran in a way that was somehow irregular and somehow unexpected. Most people who had a hexane peak and a toluene peak had something like 4 minutes for hexane and something like 7 minutes for toluene. But there were a lot of different retention times that I saw. So you'll just have to give your best explanation. Think about your data carefully. Talk about it with your lab partners, and write down what you guys conclude together. So back to the summary here. Your sample calculation is show a calculation of mole fraction, show your chromatogram photo. Okay. Also, in results and data, please also show all your chromatogram photos in here. So, mole fractions and photos. Okay. And in the discussion section, please make sure you answer these items. If your distillations, simple and fractional, showed graphs that are not looking like this, simple distillation more amorphous, fractional distillation more well-defined, if that was not the case for you, please give some reasons why. Think about that carefully. There must be a reason why. There must be a likely reason why. It is not enough, of course, to say random error or random instrument error. You have to specify which part of your apparatus would be most likely to be responsible for the error. If the fractional distillation was more amorphous in shape than the simple distillation, then what part of your apparatus was different in the fractional versus simple distillation, and how could that difference how could that difference fail you? I mean, how could your apparatus fail you in such a way? So please be as specific as you can there. Which retention time is hexane and why do you think so? Which retention time is toluene and why do you think so? So you have to identify on your gas chromatogram photo like this, which one of these is hexane, which one of these is toluene. But some of you didn't have hexane and toluene. Some of you just had one peak. Is that hexane or is that toluene? Which one would that be? So if you have one peak, notice this person has F1 here, and they have only one peak. F1, that should have been hexane and toluene, right? And they only have one peak. So why is that? Why would you only have one peak? And then in your F2 or your S2, maybe it is appropriate to have only one peak. If you think so, then why? Just a little hint. We took our gas chromatograms a week after we did the distillations, so there was some time for things to evaporate. So that may influence how many peaks you got on your chromatogram. It's up to you to figure out which one would have evaporated. If this problem happened to you, which one is it that evaporated and which one is it that stayed in your vial and to form a peak on the gas chromatogram. So please let me know if there are any questions about any of these. Thanks very much. I'm available via email. And I would like to have you finish this by Sunday night, which is tomorrow night. But this is short notice, I understand. So let me just give you another week for this. So if you can finish this at least by the following Sunday, like not tomorrow, but the following week, Sunday night, that would be great. Thank you.